Hey guys, my name is David Taylor, and today we're going to talk a little bit about NC1 files. All right, just to kind of explain NC1 DSTV files. So the first thing you're going to do if you're going to start working with these is look this up on the internet. Standard description for steel structure pieces for the numerical controls. It's a European standard. It's used across the industry to create these files. As you can see here, I have an example of a file. This is an actual one that I use for a piece of channel. And this is going to be really helpful for you guys because it's going to explain to you what each line in the code means, what purpose it serves, and you know, what you're looking at when you look at the NC1 file, and that's going to tell you what the machine's going to do. Now I have a Python X coping line. So on mine, I give it these files, and it takes the information from the file, rewrites it into its own operating code, and then executes the file. So let's see, let me go back here. I'm not really sure where to start here to explain this. So basically, you'll always have an ST and an EN in the code. Here's the ST, right, and here's the EN at the end, right? Now this one, AKV, describes the outer contour of the shape, and V, O, U, and there's an H, all describe a side of the material. So for in this instance, if you're looking at a piece of channel from the top with the two flanges facing down, the two legs facing down, this would be V, and this would be the O face, which is one side. If you took it like that and turned it, you know, or if you went like that, and then this is U. So this first column describes the outside contours, right? So, and it reads it in an X and a Y direction, right? So here is 0, 0, or 0.00 and 0.00. So I just have a little print here. It's not the same part. I'm just going to kind of use it to describe. So if we were looking at it like a graph, well, really, I should have got something different. Let's bring it down here. Well, that's fine. Okay. So let's imagine that this is, I'm just going to make up some numbers, 120 millimeters, right? Let's imagine this is, just to be simple, 300 millimeters, right? So in X direction, it's 300. In the Y direction, it's 120. So this point right here would be 0 in X and 0 in Y. So in the descriptor, the first point, and sometimes it starts here or one of the corners. So it always starts in one of the corners. Let's say it's here, and let's say this distance from here to here is 20 millimeters. All right? So your first point, if your first point is here in the file, you would have 0.00 in Y, and you would have 20.00 in X, right? And those are the first two columns, X values and the Y values, right? Okay. And then as you go along, it's really simple, guys. It's a lot like a graph. So this would be our first point, and then the next point would maybe be over here on the other side. And then in here, it would be, if this is also 20 millimeters, so the next one would be, okay, it's going to travel down to 280, and it's still going to be 0 in Y because it hasn't raised. And then the next one will be 300, right? Because we've traveled to here, and we know this is 300 millimeters across to here. And then we've gone up to 120. So you can see we started at 0, where we started our first point at 20, and we went down to 280, and then we went up in Y and also over again in X to 300 and 120. Okay, so there you go. Now, that's basically it. It just describes an outside shape, and then it'll have different information values in it. So right here you'll see the BO, right? That describes a hole, right? And then the V tells you which face it is, and then these tell you where the hole is located. Also, you'll see there's deals for slots, holes, and if you look at here, right, another thing you'll see is in the fourth column a lot, there's an angle. So if the machine needs to cut a bevel, it'll have the degree angle in here on the fourth column. But really, just you need to print out the standard and just use it, because this is, see these profile descriptions of the different structural shapes, right? Describing what face you're looking at and why. There you go. So all this stuff that I was just talking about is all contained in this. Here you go. That's a good one. So there's the faces, and then X, Y. If you have a threaded hole, and these are all different pieces of information, and it'll change a little bit from machine to machine what it does, what it looks like, where you need to put the columns at. So I advise talking to the manufacturer if you have any questions, or if something doesn't seem to be working quite right, as far as where those, what column the information that you're trying to get the machine to do is located. All right, so that's basically it. If you have any more questions, feel free to let me know. And as always, y'all have a good one.